Well, students, in this video, we're going to cover at least one example from the homework in section 10.4 on analysis of variance. So I encourage you to read the section carefully so you can answer that first question, which asks, what conditions are necessary in order to use a one-way ANOVA test? Okay, yeah, so which conditions are necessary, and then it says select all that apply. So you can find the conditions on page 559. So before we do an example from the homework, let's go over some basic information that you should know. So the basic setup of the null and alternative hypotheses in this section is that the null hypothesis will always be all the means in question are equal. Okay, so remember, in a one-way analysis of variance, okay, you are comparing three or more population means. Okay, so in the null hypothesis, right, you assume that all the means that you are comparing are the same. Okay, so then in the alternative hypothesis, right, it will be that at least one of the means is different from the others. Okay, so there's actually more than one way to more than one way that can happen. Okay, so if you compare three means or four means or however number of means that you're comparing, right, there's more than one way where at least one of the means is different from the others can happen. Okay, so usually in the alternative hypothesis, right, we make a general statement such as this, right? At least one of the means is different from the others. Okay, so the requirements for performing a one-way analysis of variance hypothesis test are given on page 559. All right, furthermore, the hypothesis tests in this section are all right-tail tests. So if you read page 559 carefully, right, there's a little paragraph below this box here, right, and it says all one-way ANOVA tests are right-tail tests. So you want to keep that in mind. So what that means is that in the course of doing the homework, right, you will be asked to find the critical value of the test and to calculate the value of the test statistic. Okay, so to find the critical value for these types of tests, you will use the F distribution calculator in StatRich. Okay, because as it turns out that when the requirements are met for this type of test, okay, the test statistic, which is given by this formula, right, follows what's called the F distribution, okay, which is another type of probability distribution. Okay, so notice how the capital letter F is used in that formula. Okay, so that's why in StatRich we use the F distribution calculator. So be sure to identify the significance level in the problem. Okay, the numerator degrees of freedom and the denominator degrees of freedom. Okay, so you may have noticed that when you look at the formula for the test statistic, right, it's expressed as a fraction. Okay, so you have some expression on top and then some expression on the bottom of the fraction. Okay, so for this type of test, there are two degrees of freedom that you look at. So that the degrees of freedom in the numerator, okay, and the degrees of freedom in the denominator. Okay, so the numerator degrees of freedom is equal to k minus 1, right, where k is the number of means you are comparing in the problem. Okay, so the value of k is also equal to the number of samples that you have. Okay, so if you're comparing three means, right, then you will have three samples. If you're comparing 5 means, you will have 5 samples. Okay, so the numerator degrees of freedom is the number of means that you have minus 1. Okay, the denominator degrees of freedom is equal to capital N minus k, right, where capital N is the total number of data values from each sample. All right, and this will all make more sense when we do an example. Okay, so let's go and look at problem 2. Okay, and it says that the table to the right shows the cost per ounce in dollars for a random sample of toothpastes exhibiting very good stain removal, and fair stain removal. Okay, so at a level of significance equal to 0.05, can you conclude that the mean cost per ounce are different? Perform a one-way analysis of variance test by completing parts A through D, and assume that each sample is drawn from a normal population. The samples are independent of each other, and the populations have the same variances. Okay, part A is asking us to identify the claim and state the null and alternative hypotheses, and then choose the correct answer. Okay. So again, the null hypothesis is that all the means in question are equal to each other. So each mean represents the mean cost per ounce. Okay, for all toothpastes, or for the different levels of stain removal. Okay, so the first mean would be the population mean. Okay, for all population mean cost per ounce for all toothpastes that have very good stain removal, and then the second mean would be the population mean cost per ounce for all toothpastes with a good stain removal, and so on. Okay, so in the null hypothesis, right, we assume they're all equal to each other. Okay, then in the alternative, right, we simply look for the statement that says at least one of the means is different from the others. Okay. So you can look at the answer choices carefully. All right, so it's between A and B. Okay, so if you carefully read the problem, it says, can you conclude that the mean cost per ounce are different? So that means that the Klamer testing is going to be the alternative hypothesis. So answer choice B would be the correct answer there. Okay, part B, it says to identify the degrees of freedom for the numerator and for the denominator, and then determine the critical value and determine the rejection rate. Okay, so going back to our notes here, right, remember the numerator degrees of freedom is equal to k minus 1. All right, and k is the number of means you have in the problem. All right, so since we have 3 means, right, we're comparing 3 means in our problem, right, then the numerator degrees of freedom would be 3 minus 1, which is 2. All right, and once again, the denominator degrees of freedom is equal to the total number of data values, okay, from each sample minus k. All right, so what that means is you count the number of data values, okay? So you see that there are 15 data values. All right, so the numerator degrees of freedom would be 15 minus 3, so it would be 12. I meant the denominator degrees of freedom. So the denominator degrees of freedom is 12, so 15 minus 3, which is 12. All right, so based on that information and the level of significance, we're going to calculate the critical value. Okay, so let's go to StatCrunch, and we're going to go ahead and open up the F distribution calculator. So go to the Stat menu, Calculators, select F for the F distribution. And remember, one-way analysis of variance tests are right-tailed tests. So you're going to select the greater than or equal to symbol. Okay, so make sure the standard box is selected. Okay, so the numerator degrees of freedom was 2, and the denominator degrees of freedom was 12. Okay, and our level of significance was 0.05. Okay, so we're going to enter the level of significance in this box here, and then the critical value will appear here. All right, and then it shows you the rejection region. So this is the critical value, so 3.885. All right, so the part of the diagram in red is our rejection region, okay, which is to the right of that value, 3.885, because that's our critical value. So 3.885. Okay, sometimes it'll dock you for including too many decimal places, so it wants it to two decimal places, right? Not three. Okay, so it'll be 3.89. Okay, so the rejection region is that it's greater than or equal to that value, right? So you're going to retype that value in. Okay, so not doing very well here. So again, so if it's not greater than or equal to, it's greater. All right, so then we're going to calculate that test statistic. Okay, so what we need to do then is input the data into StackCrunch. Okay, so we're going to copy it. Okay, so there's our data. And we're going to go to the stat menu, select ANOVA, select one way. All right, and we're going to select the three columns that contain our data. Okay, make sure you hold down either the control button or command button as you select the columns. Okay, and then there are several options, okay, that you can select, but we're going to ignore many of these options. So let's go ahead and click Compute. Okay, so it gives you a summary of your data. So the number in each sample, the sample means, the sample standard deviations, and so on. Okay, so what we're looking for is that test statistic. Okay, so it's underneath the fstat. And it says it wants it to 3 decimal places, right? So to 3 decimal places, it's 0.668. Okay, so in part D it says decide to reject or fail to reject the null hypothesis and interpret the decision in the context of the original claim. Okay, so our test statistic was 0.668. Our critical value was 3.89. Okay, so let me pull up that graph again. So this was our rejection region. Okay, so our critical value is here at the edge of the rejection region. Okay, so our test statistic 0.668 okay, is between 0 and 1, so it's way over here, right? So we can clearly see that our test statistic is not in the rejection region, so we are going to fail to reject the null hypothesis. Okay, so read the answer choices carefully, select the best one. Okay, so because the claim was represented by the alternative hypothesis, and we did not reject the null hypothesis, right, what that means is that there is not enough evidence at the 5% level of significance to support the claim, okay, because it's given by the alternative hypothesis. So to support the claim that the mean cost per ounce is different, okay, for at least one of the products. Okay, and we've completed question 2 in the homework for section 10.4. Thank you for watching.